Yes, welcome back to the session. In this video, I am going to discuss about applications of Coulomb's law. Okay, so this topic is most important for NEET as well as JEE students. Okay, so look at this diagram here. We have two charges. Let's say, for example, I'm taking the charges like Q and Q. That means two like charges I have taken. Okay, so which are suspended with the help of strings. Say for example, the length of the string will be L and which is fixed at rigid support. That means the two strings are fixed at rigid support. So whenever two charges are same charges, then definitely these two charges repel each other with some force. So one force is acting in this direction and the other force is acting right side. Correct or not? But each and every charge having some mass, right? So due to that mass, the total weight of the first charge which is acting vertically downward direction, so weight is nothing but mass into acceleration due to gravity. Similarly, for second charge also, weight which is acting vertically downward direction. Okay, so whenever string is present, then definitely tension will be developed, right? So the tension always acting towards the rigid support. Okay, now I'm taking a horizontal line. Okay, so from center point to between the two charges, the distance of separation I'm taking x, and this is also x. Let us assume this is the midpoint O. Okay, now this string makes an angle theta with respect to the mean position. So this is also makes same angle with respect to the center. Okay, now I'm going to resolve this into two components. One is a cos component and the other one is sine component, right? So I'm just extending opposite side. It makes an angle theta. So this component will be t cos theta. Okay, and perpendicular component means here, that will be t sine theta. Okay, so from this diagram, look at this diagram carefully, where f is equal to t sine theta, right? So I'm going to write f is equal to t sine theta. Let us assume this is equation number 1. Similarly, weight is balanced by t cos theta, right? So we can write it as weight is nothing but mg. So mg is equal to t cos theta. So let us assume this is equation number 2. So after getting this equation 1 and 2, I'm going to divide 1 by 2. That means how to write this one? F by mg is equal to t sine theta by t cos theta. Okay, so t cut. Finally, f by mg is equal to sine theta by cos theta means tan theta, right? Okay, now I'm going to take this mg right side. Therefore, f is equal to mg into tan theta. Okay, so this is the expression for force. So finally we got f is equal to mg into tan theta. Now look at this equation 1 and 2. So what I'm going to do here, I'm going to squaring and adding on both sides. Therefore, that means 1 square plus 2 square, which is equal to, that is I'm going to do. So 1 square means left side we can write it as f square plus mg square is equal to t square into sine square theta plus cos square theta. Okay, so we know that sine square theta plus cos square theta value will be 1. So therefore, we can write it as f square plus mg square is equal to t square. From this, t is equal to under root f square plus mg square. Okay, so this is the expression for tension. Okay, so we got two important formulas here. One is a force formula and the second one is a tension formula, right? Still continuation is there because this topic is most important for JEE also. Let's see what I'm going to do here. Now what I'm going to take here, I'm going to use this first equation. What is the first equation? F is equal to mg tan theta. Okay, so before that, here also look at this diagram carefully. We have two charges, right? So with the help of these two charges which are separated by a distance x plus x 2x. So what I'm going to do here, according to Coulomb's law, according to Coulomb's law. So what is Coulomb's law? F is equal to 1 by 4 pi epsilon naught into q square by the distance of separation I told you already, x plus x. The total becomes 2x whole square. So this expression we can write it as F is equal to 1 by 4 pi epsilon naught into q square by 4x square. Okay, so this is the Coulombic force. Let us assume one second, this is expression 3 and I'm going to take this expression is equation 4. Now what I'm going to do here, this force formula I'm going to substitute in 3. So I'm going to mention here, substitute equation 4 in 3. Okay, therefore F means clearly I told you already. One second. So we can write it as 1 by 4 pi epsilon naught into q square by 4x square, which is equal to mg into tan theta, right? Okay, now I'm going to find the angle tan theta is how much. Okay, so for that I'm going to choose a triangle here. Let us assume here we have one charge, right, and midpoint will be O, and this will be the rigid support. Okay, so from this triangle here theta will be there. We know that from that angle tan theta is equal to opposite side by adjacent side. Okay, so here opposite means x and adjacent side will be, I think, L, correct or not? So I got tan theta is equal to x by L. This formula I'm going to substitute here. Just a second. So 1 by 4 pi epsilon naught into q square by 4x square is equal to mg into x by L, because tan theta value I got this much. Okay, so after getting this equation, now I'm going to take x terms and all one side. Here x square will be there, here also x will be there, right? So x square into x becomes x cube. So x cube is equal to 1 by 4 pi epsilon naught into q square by 4 into L by mg, correct or not? So this is the expression I got. Now this cube term also I'm going to take right side. Therefore x is equal to q square L by 4 pi epsilon naught into 4 mg whole power 1 by 3. Okay, so by seeing this expression, clearly we can understand x cube is directly proportional to q square, because this term will be previously left side, right? So x cube is directly proportional to charge square, right? Or x is directly proportional to q power 2 by 3. So sometimes these formulas also most important, especially for solving JEE problems. Okay, so still continuation is there. Not only the distance of separation from the center, we can calculate discharge with respect to time. That means rate of discharge. Okay, so that is also we are going to find from this expression. Okay, let's see, just a second. Now the next thing we are going to calculate discharging at constant rate. Sorry, just a second. Yes, discharging at constant rate. Discharging at constant rate. That means dq by dt, which is equal to constant, right? So this is the thing we are going to prove now. Okay, so look at this equation carefully. X is directly proportional to q power 2 by 3 I wrote, right? Correct or not? So that means from this expression clearly we can understand q is directly proportional to x power 3 by 2. Am I right? Now I am going to differentiate this charge with respect to time. That means dq by dt, which is equal to some constant k into this 3 by 2 will comes here, right? 3 by 2 into x power 3 by 2 minus 1 into dx by dt. That means displacement by time is called velocity, right? So this term we can write it as velocity. So here dq by dt means what? This is nothing but constant. Am I right? So therefore constant, which is equal to, what is the remaining term here? If k value is equal to 1, then 3 by 2 into x power 3 by 2 minus 1 means that is nothing but 1 by 2 into v, or we can write it as x power 1 by 2 into v. That means this term x power 1 by 2 into v, which is equal to constant. Okay, or we can write it as this expression v is inversely proportional to 1 by root x. That means velocity with respect to distance. That means initially the charge will be at the center. Whenever two equal and opposite, whenever two equal charges was present, these two charges are repel with each other and moving outward direction, right? So whenever it is moving outward direction, definitely a speed is developed. So we calculated speed formula also here, correct or not? So v is inversely proportional to root x. Okay, so this topic most important, especially for NEET and JEE students. Okay, so not for board level. I hope you understand. Thank you. We'll meet you again in next class. Bye bye.